Yesterday we have talked about the two algos, best first search and A star algo or asterisk algo. Now we will talk about some game playing algos, minimax algo and the and or star algo, or we simply say that AO star algo or AO asterisk algo. सर्च टेक्निक के बारे में डिस्कस करेंगे. So what is a game playing first, or what comes under the game playing? Simple, we will take an example of tic-tac-toe also in this. Here the game playing is given that the adversarial search or the game tree search. Adversarial search का मतलब क्या होता है? It's a search technique in which we are basically showing the competition between the agents. Definitely, when we are talking about the game playing, we are somewhere discussing about the competition between the agents, or simply we can say that adversarial search is a technique or that simulate the competition between the intelligent agents. And we can use in types of a game like we are using the tic-tac-toe, the chess game, various games that can be worked. So first we need to understand the problem. First we need to understand the characteristic of a problem or the characteristic of a game, which basically we will decide what mathematics or the concept we need to use in this. Then the game involved the various intelligent agents or the multiple agents involved. So we will search for a solution in that by considering the multiple agents, and we will search for a conflicting goals also. And we will when we are applying the search technique in search in the adversarial search or the game tree search, when we are using, then definitely the agents takes turn making moves, and the goal is to anticipate the opponent move also, right? The another goal of a first player is to what the other move can be from the opponent or the another player, and it should be respond accordingly. So in this we are basically talking about what outcomes, what possible outcomes can be there, and what we will in game playing, definitely we are talking about what the opponent's strategies will be there. So for the game playing purpose, we will talk about today the minimax or the minimax algorithm, which is a technique which is used to search the game tree, determine the optimal strategy for maximizing the player. And we will basically use this minimax algorithm, which alternate between calculating the maximum and the minimum value. Somewhere first we will calculate the maximum, then we will calculate the minimum values. So today we will talk about minimax problem and the gameplay. So let's, and then we will talk about another algo, the AO star algo, which is the advanced version of your A star algo, which we have discussed yesterday. So what comes under the game playing? The adversarial search or the game tree search is a technique for analyzing the adversarial game in order to determine who can win the game and what moves the player should make in order to win. So somewhere the predictions are involved, right? And we are talking about the predictions or the strategies to be made according to the opponent, and we need to analyze a game according to the players, what the multiple agents are involved in them, and who can win the game. Adversarial search is one of the oldest topic in the AI, and the original idea for this was developed by the Shannon in 1950 and independently by Turning in 1951. In context of a guess of a chess, and their ideas still form the basis for the techniques used today also. So here the example is given. When we are talking about the two-person games or the players, here we can call them max and minimum. So here we will talk about max minimum minimax problem. What comes under this? The initial state includes the board position and whose turn it is, right? Initial position is basically the board position and the whose turn is there and what move he can do. So initial state will be decided here, and then we will talk about what will be the operators that corresponds to the legal moves. The person or the player who is playing, what he can do or what the legal moves are allowed to him. Then the terminal test will be performed. A test applied to a board position which determine whether the game is over. In chess, for example, this could be checkmate or the stalemate situation, right? So first, definitely the initial state of a game is that the initial state of a board and the whose turn is this and what another step is the operators or the player can move the particular वो अपना जो move करेगा these correspond to the legal moves and the terminal test whether the game is over or it is still in a game. Then we are talking about a utility function. What's a utility function? A function which assign a numeric value to a terminal state. For example, in the chess, the outcome is +1 for the win and -1 for the loss and draw for the zero. So what is the terminal state here? When we implement any game, so we will talk about what will be the final value of the terminal state, whether it's +1, -1 or 0. If it is a +1, the player will be win. And if it is a -1, he has lost. Or if it's 0, then it means it's a draw. Note that by convention, we always measure utility related to the maximum. Right? Now, what is the mini-max problem? Minimax algorithm generate the whole game tree from very initial state, then apply the utility function to leaf nodes to get their values. To get their values to the leaf nodes or to the child nodes, it apply the utility function, which basically decide the which basically assign the numeric value to each leaf node. Use the utility of the nodes at the level n or at any level to drive the utility of a node at the level n-1 as we move forward. Continue backing up values towards the root, one the layer at a time. So we will move from bottom to top. Eventually, the backed up values reach the top of the tree, at which point max choose the move that yield the highest value. And this is called minimax decision because it maximizes the utility for the max on assumption that minimum will play perfectly to minimize it. So how it will work? Definitely, first we will use the utility function. Here you can see the algorithm is a depth first version in the minimax. To determine the minimax value of a particular node, we will use if j is a terminal for a node and return if it is a terminal the term. Otherwise, we will generate the successors of a j and we will evaluate from left to right each value. And if j is a max node, then we will return a max utility function to it. And if it is a minimum node, then we will return a minimum unit here. So first one will be the decision whether it is a terminal state or not, and then next one will be the other to finding the other successor. So here we are taking an example of a max minimum. Here the initial or the root node is A and the further nodes or the leaf nodes of a A is B, C and D, and the branching is A1, A2 and A3, and after that the B is there which is having a further leaf nodes by branching the B1, B2, B3, and it's having its cost here the 3, 12 and the 8, and C is having the further leaf nodes and it having a cost here 2, 4 and 6, and further D is having the leaf nodes which having the further values here. So how we will start? We will start from from bottom, which is the minimum, and then we will form the maximum, and then the minimum, and then the maximum. So from the lowest level or the you can find that from the lowest level, the 3 leaf nodes are there, 4, 3 and 5. And what we are performing here, the minimum value or the minimum function here. And in between the 4, 3 and 5, you can see here in the 4, 3 and 5, basically 3 is minimum. So the further parent node will have a value 3 in form of a minimum. Then all the nodes value will be calculated based on a minimum function only. And another leaf nodes, the two one, the minimum is 1. Then another leaf nodes are 4, 2 and 3 and the minimum value is 2. And then other leaf nodes are, so here you can see here in the minimum level, all the minimum values has been calculated. How it has been calculated? Based on a minimum function. We will apply first the minimum function. We are using the minimax problem here. So from all the leaf nodes, the minimum value will be given to a parent node here. So here from first node, here the value will be 3, then 1, then 2, then 4, 7, 2, then 0 is there because here the leaf nodes have a value 1, 4 and 0. So the 0 will be there. Then from 5 and 3, the 3 will be there. From 0, the 0 will be there. And again from 2, 7, 4, the 2 will be there. And 3, 6, the 3 is the minimum. And in between 5, 3 and 1, the 1 is minimum. So here our first level has been completed. Then we will move to the another level. And in that case, we need to find the maximum. So here we are using just an alternation between minimum and the maximum. First we have done the minimum and then now we are finding the maximum value. So the leaf nodes are here 3 and the 1 and the maximum value is 3. So we will put 3 here. Again here the 2 will be there, the 7 will be there, 0 will be there. In this case the 3 will be there and in this case the 3 will be there. So another level will be completed according to maximum value, right? So here the values are 3, 2, 7, 0, 3 and 3. Now based on again minimum, we will find the minimum value. So in the second level from top to bottom, we have to find the minimum value. Again the alternation according to the alternate function. Here we'll have the value 2 and here we will have the value 0. So here again after completing the tray, the 2 and the 0 will be there and then the root node will be at 0 and we will find the root node here. So here the and the root node will be at 0 and we need to find the maximum value. So we will find here the 2 here. So this is the value from 2 to 2 and then 2. This is the complete value of finding the root here. So here we had find according to the minimax problem how the minimax problem works. The minimax problem works according to a minimum and the maximum value alteration. It will provide the alternate calculation. So what is the property of a minimax here? Complete, yes. If the tree is finite, it is definitely complete. Optimal, yes, against an optimal opponent. Time complexity, B is here the branching factor, right? So here we are choosing the time complexity B to power m. Then the space complexity is B m here. So here the depth first exploration according to a depth first algorithm, or when we consider the depth first, the space complexity is definitely the Bm. And for chess, we can say that if the branches factor is a 35 and the m is the 100 for the reasonable games, the exact solution completely infeasible. So here again, the exact solution will not be there, but not always feasible to traverse entire tree when there is a number of here we can say that when the branches are 35 here and it will approximate the 100 are there, so it will be definitely limitation when the problem will be very big, not always feasible to traverse the entire tree, and the time limitations are there when we, because here we need to traverse the complete tree here. Now for this we will see the further improvement or the further algorithm in this, the alpha beta pruning algorithm. We have discussed about the minimax algorithm, how it works. It works according to the minimum and the maximum function, generating the minimum and the maximum function in this example. With the help of a graph, you can see here, and with the help of an algorithm, we can understand that first the function minimax decision state return an action whether it will perform the max value and return the action in a successor with the value b. And then function max value return a utility value. If the terminal test, we will perform the terminal test, and if then it return the utility state is infinity, then the further the looping will be performed here. Or simply we can determine according if the particular node or the j is the terminal, then the it will be terminate, otherwise it will generate the other successors according to the max node and the minimum node. So how it generate the whole game tree, apply the utility functions to leaf nodes to get their values, and according to the utility of the nodes at a level, and it drive the another utility of the nodes and continue the backing up whole values towards the root one layer at a time here. And it works basically on the alternation of a maximum and the minimum. Eventually, backed up value reach the top of a tree, at which point max choose the move that yield the highest value, and this is called the minimax decision because it maximizes the utilities for the max on the assumption that the minim will play perfectly to minimize it.